Chapter 6, Lesson 8 is going to be focusing on solving two-step inequalities. So basically what we are going to be doing in this lesson is we're going to be taking all of the information that we have learned in prior lessons of Chapter 6 and kind of take that new information and combine it all together. This time though, working and focusing on inequalities. In a previous lesson, you guys had worked on solving two-step equations. Okay, so that's going to be very similar to this, except for we're working with inequalities. The other thing we have to remember is with inequalities, if we're going to be multiplying or dividing by a negative number, we have to make sure that we reverse that symbol. Okay, so let's take a look here. Again, our objective for the day is going to be able to solve and graph two-step inequalities. We do have one vocab word here in the lesson that you're going to want to make sure that you get filled in. It's two-step inequality. Okay, and so what I'm going to do here is I'm going to turn to page 514, and we're going to go ahead and start looking at two-step inequalities and what they are. Okay, so two-step inequality is very similar to two-step equations. If you think back to two-step equations, what happened was we had two operations. You have your numbers and you have your variables. So two-step inequality is going to be that inequality. So remember, that's going to be your less than, greater than, less than or equal to, or greater than or equal to symbols. We're going to have two operations, okay, that are going to be in it. Could be multiplication and subtraction, could be division and addition, multiplication and addition, or division and subtraction. Those are the main operations we're going to be focusing on. Okay, when you're solving it, you're going to be using your inverse operations. So again, we're going to be thinking about our addition and subtraction properties of inequality, along with the multiplication and division properties of inequality when we work through these. Okay, so let's go ahead and take a look here at number 1. Again, they're giving us a two-step inequality, and they're also asking us to graph this on a number line. So let's take a look here. We have 3x plus 4 is greater than or equal to 16. If this was 3x plus 4 was equal to 16, okay, the first thing that we would do is get rid of whatever's being added or subtracted. So in this case, we're adding 4. So the opposite you can see would be to subtract 4, solving it the same way. 4's are going to cancel out. 3x is left, is going to be greater than or equal to 16 minus 4 is 12. Now, once I do that, I'm technically looking at a 3x is greater than or equal to 12. What do you do to both sides? You're going to divide both sides by 3. So those are going to cancel. 3 is a positive number, so your inequality symbol stays the same. 3 divided by 3 is 1, so I have x left is greater than or equal to 4. 12 divided by 3 is 4. Now let's take a look at how we would graph that. I know that my answer is going to be greater than or equal to 4, so because it's including 4, I'm going to put a closed circle on 4. I'm looking at numbers that are greater than 4, so I'm going to graph to the right. Now I'm going to go back and check that. Let's pick the number 7. So I'm going to plug in 7 for x. Is 7 greater than or equal to 4? Yes, it is, so I know it's graphed correctly. Okay? So there's one example of a two-step inequality and graphing it. Let's take a look at example number 2. We've got 5 plus 4x is less than 33. Again, think of this in terms of what we did for equations. We've got our variable over here, and 5 is being added to it. So the opposite of adding 5 would be to subtract 5. So we're going to subtract 5 on both sides. So my 5's are going to cancel out. 4x is left. 4x is less than 33 minus 5 would be 28. Now, looking at both sides, what do I want to do? I want to divide both sides by 4. So those are going to cancel out. X is going to be less than 7. Now I need to graph that. One thing before I graph it, just to remind you guys, this is being divided by a positive number, so the inequality symbol is going to stay the same. So x is less than 7. I'm not including 7, so I have an open circle on 7. Numbers less than 7 would be graphed to the left. So your book is darkened in numbers to the left. Now I'm going to check it. Let's pick the number 2. Is 2 less than 7? Yes, it is, so I know that it's graphed correctly. One of the things that I would strongly encourage you to do as you're graphing these is to go back and double check to make sure that when you have darkened it in a specific direction, that those numbers that are there match and make that work. Okay? Let's take a look at letter A, and we'll work on this one together here. It says solve 2x plus 8 is greater than 24, and then we're graphing it on the number line provided. So I'm going to write this over here so I have some more room. Okay, so here's my variable, and I'm adding 8, so the inverse would be to subtract 8. So I'm going to subtract 8 on both sides. So 2x is going to equal 16. I'm going to divide both sides by 2. I'm sorry, not equal, greater than. So 2x divided by 2 is going to be x. I'm dividing by a positive number, so my symbol, my inequality symbol is going to stay the same. 16 divided by 2 is 8. So x is going to be greater than 8. Now, let's take a look. I'm going to go ahead and graph this. Put 8 in the middle, 9, 10, 7, 6. X is greater than 8. I'm not including 8, so it's going to be an open circle. And numbers that would be greater than 8 would be graphed to the right. I'm going to darken it into the right. And then I'm going to double check to make sure that I'm correct. So I'm going to pick the number 10. Is 10 greater than 8? Yes, it is, so I know that I did that correctly. Okay? Let's go ahead and continue on to the next page, or page 515. We're going to go ahead and take a look at those examples on 515. Okay, now a couple differences on these that you're going to notice is now they're implementing more negatives. So remember from our previous lesson, anytime we're multiplying or dividing by a negative, we have to make sure that we reverse our inequality symbols. So let's take a look. We've got 7 minus 2x is greater than 11. So the first thing we would do is 7 is positive. So because 7 is positive, we're going to subtract 7 on both sides. So you can see that they've subtracted 7. 7 minus 7 is 0. So I've got negative 2x left is greater than 11 minus 7 is 4. Now the next step for me to solve this would be to divide both sides by negative 2. Because I'm dividing by a negative, we have to reverse that symbol. So it's no longer greater than, it now becomes less than. Negative 2 divided by negative 2 is x. We flipped this or reversed this, so it's less than. 4 divided by negative 2 is negative 2. Then we can go ahead and graph it. I'm not including negative 2, so it's an open circle. And I'm looking at numbers that are less than it, so I'm graphing it to the left. So please, again, make sure when you're working with those negatives, in terms of multiplying or dividing, that we end up reversing that symbol. Okay? Example 4. Look at x divided by 2 minus 5 is less than negative 8. Okay, so let's look at what we're adding or subtracting. We're subtracting 5. So the opposite of subtracting 5 is to add 5. So I'm going to add 5 to both sides. X divided by 2 is left, is less than negative 8 plus 5 would be negative 3. Now, in order to solve this, we're going to have to multiply both sides by a positive 2. Okay? Because it's positive, my inequality symbol is going to stay the same. So 2 divided by 2 cancels out to become 1x is less than negative 3 times 2 is 6. And then moving on and looking at the graphing aspect of it, x is less than negative 6, so I'm going to have an open circle on negative 6, and I'm talking about numbers that are less than, so I'm graphing it to the left. Now, just to check it, okay, negative 8, is negative 8 less than negative 6? Yes, it is, so I know it's graphed correctly. Okay, what I would like you to do right now is to go ahead and try letters B and C on your own. You're going to solve them, graph them, and then come back and after you're finished, turn your video back on and check to see if you agree with mine. All right, let's go ahead and take a look at got it problems B and C. First thing that I had done was subtracted 9 on both sides, so those are going to cancel out. X divided by 2 is greater than or equal to negative 4. 5 minus 9 would be negative 4. I'm going to multiply both sides by 2. So x is left, x is greater than or equal to negative 8. So when I take a look at my graphing, I'm looking at a closed circle because I'm including negative 8. I'm looking at numbers that are greater than, so I'm going to go ahead and graph it to the right. I'm going to check it. Is negative 6 greater than negative 8? Yes, it is. Okay? Letter C, 8 minus, and then I've got x divided by 3 is less than or equal to 7. So the first thing I'm going to do is subtract 8 on both sides. 8s are going to cancel out, so then I've got negative x divided by 3 is less than or equal to negative 1. Now what I want to do is multiply by negative 3 on both sides to get rid of the negative that was ahead of it. So I'm going to multiply by negative 3 here and multiply by negative 3 there. Those are going to cancel out. X, I have to make sure that I reverse my inequality symbol. It was less than or equal to, now it needs to be greater than or equal to. So negative 1 times negative 3 becomes positive 3. X is greater than or equal to 3, so I've got a closed circle on 3, and I'm graphing it to the right. Hopefully you were able to come up with the same one as me in terms of answers. All right, let's go ahead and take a look real quick at the top of page 516. What they're giving you at the top here is just a real world problem that I want to take a look at really quick here. It says halfway through the bowling league season, Stuart has 34 strikes. He averages 2 strikes per game. Write and solve an inequality to find how many more games it will take for Stuart to have at least 61 strikes. Okay, so let's think about what we know. He averages 2 strikes per game and he already has 34. He needs at least 61. So let's set this up. 2 strikes per game plus the 34 points that he has, and it needs to be at least, so this needs to be at least 61 or greater than. So we're looking at greater than or equal to 61. So when they solve that, first of all, they're going to subtract by 34 on both sides. Okay. So then I have 2g is greater than or equal to 27. Divide both sides by 2. So g has got to be greater than or equal to 13 and a half, which means then he's probably not going to bowl a half of a game, so he's going to have at least 14 more games to have that, at least 61 strikes. So what I would like you to do right now is to go ahead and take a look at the website and take a look at which extra practice problems on page 519 I would like you to do.